Hi everyone. So this is the lesson 4, working with constraints. This is going to be day 1, and tomorrow, the next lesson, we will be doing day 2, and we'll be done with the unit, and we'll go into our review. So we're on page M2 185, and on the left-hand side, as you can see, we were looking for points that work, right, for this situation. So if you look at the point 3, 4, if we plug them in here, x plus y is less than 18. As long as it's less than 18, we're good to go, right? So some people pick 3, 4. So 3 plus 4 is 7. 7 is definitely less than 18. And another person picks 6, 7. Another put -8, -4, right? So these are all points that would work. And so if you take a look at this graph right here, let me just make it so that it's a little bit smaller. All right, and if you notice right here, so this is where x plus y is less than 18. And if you notice, I'm going to plug in the points 3, 4. You notice where it is. And same thing with 6, 7. And also -8, -4. Right? And if you notice, in that one you can't see because it is over here. If you notice right here, they're all in the shaded area. What? Right? And the reason why is because this whole shaded area, this is where all the any point in the shaded area is gonna work. And which means in the other sense, any point that we pick that is outside of this shaded area is not gonna work. Like for example, if we pick the number 10, 15, right? So 10, 15, put it right here. So this is 10, 15. You see how it's outside there? That's not gonna work. So if we add 10 plus 15, that would give us something that's 10 plus 15 is 25. 25 is definitely not less than 18, right? So this definitely would not work, just like what we said. So anything in the shaded area is what we want to see. Okay, and algebraically, this is what we would do, and graphically, this is what it would look like. If we take a look at the points, delete those guys for a little bit here. If we look at this second one right here, we have 4, 6. You notice 4, 6 is right here at in the shaded area. Same thing with 2, 1, 2 over to the right 2 and up 1. Again, shaded area. So these all work. And if you notice here algebraically, 4 minus 6 is -2. -2 is definitely bigger than -7. All right. And then over here, we'll just do the next one. All right. So here's the graph, the inequality. And if we plug in -2, -3, oh, -2, -3, oh, -2, -3. Ooh, -2, -3 does not work. What? Let's take a look. We did this over here, right? So -2, -3. -4 plus -9 is going to be -13. Is less than or equal to -5. But it says it doesn't work. Let's just make sure. So we got, oh, do you see here? So 2x plus, this should have been a plus right here to you. So plus 3y. There we go. That's what it, so this is what it should look like. And if we put -2, -3 in there, -2, -3, yes, it's definitely in the shaded area. So you're good. And when you look at this solid line right here, so if the point is exactly on the solid line, that's okay too, because it's a solid line, so it's part of that shaded area. If it is like number 2, where do you see it's dotted like this? So this one does not say equal to on the bottom, it just says greater than, which means this line is not part of the shaded area. It is just the fence, it's just the border line, but it's not in the shaded area. Okay, so that's why we have that dashed line just like that. Okay. Something to take note. So any point that's on this dashed line, like right here, -10, -3, is not a point that works here. All right, and then for the last one, let's try that last one right there. Let's see if any of these points work. Yep, the only point that works is -8, -4, right? That's going to be the one that works the most. Actually not works the most, though that works, period. Okay, because it's in the shaded area. Notice these two not in the shaded area, so those are not going to work in this inequality. And if we were to check it, like this is 3, 4. So if we put in 3, 4, So negative 5, 3 times 4, negative 2 minus 4 times 4, greater than or equal to 10. So this is going to be negative 15 minus 8. And this is going to be negative 23. And as you can see, negative 23 is not greater than or equal to 10. That is a no-go. It should just be one line like that. Okay, that doesn't work. All right, so that's what we said, it was not going to work. And there we go, it didn't work. All right, so we're going to be representing constraints in problem situations with systems of inequality. Write and graph systems of linear inequalities and graph them. Okay, this is what we're going to do. So a river runs through it. I don't know if you ever been rafting. We were talking about it in class today. So hopefully you were there, but if you weren't, that's okay. Come next time. So basically Chase is a white water rafter who guides groups of adults and children out on the water for these amazing adventures. And so the raft he uses can hold 800 pounds of weight. This is important because if you exceed the 800 pounds of weight, it could do a couple of things here. It could either cause a raft to sink, bad days. It could hit more rocks, which means tear the boat, bad days. That boat is expensive. Or number 3, it can maneuver more slowly, which means not a very amazing adventure. It's a very slow adventure, right? So we don't want any of those things to happen, or either any combination of those things to happen. So therefore, should be up to 800 pounds, nothing more than that. And then Chase estimates the weight of each adult as approximately 200 pounds, plus or minus, right? The weight of each child is approximately 100 pounds. And Chase charges adults $75, children $50, and to ride down the river with him. His goal is to earn at least $150 each rafting trip. That's his goal. Like, or else it's like for him, maybe it's not worth his time, right? Maybe it just costs more to, to do it any less than that. So here we go. It says writing inequality to represent the most weight Chase can carry in terms of rafter. So if you're looking at this, just the weight section, it's going to be 200 pounds. And we decided that X is going to be the number of adults and Y is going to be the number of children. So knowing that, so we'll say 200 because each adult is about 200 pounds, give or take. So 200X plus 100Y because one child is about 100 pounds, give or take. And then that's going to be less than or equal to 800. So it can be equal to it. It can be less than it. Definitely cannot be greater than. So definitely make sure you check your signs on that or your inequality on that. And this one right here, now looking at just the money part, right? This one was the weight, right? So this is the weight. And this is for the moolah, right? So it's that $75 per adult and $50 per child. And he wants to get greater than or equal to $150, right? So if you take a look at this, these are what we call constraints, right? These are things that we're like, okay, these things need to happen. So in other words, it's constraining. We can't have an unlimited amount of adults and children in the boat, right? Because of the weight restriction. And we do want a certain amount of money. We, meaning Chase, wants a certain amount of money for each trip. So this together, for these two things combined, they are called system of inequalities. Okay, or more specifically, system of linear inequalities. Those two right there. Okay, could we have more than that? Because can we have more constraints? Yeah, we totally can. But for now, we're just going to deal with 2. Okie dokes. So if you take a look at this, this is what we talk about, constraints. So here I just copied down the inequalities here. So on the first trip, Chase guides 2 adults and 2 children. So what does that mean? So we plugged in 2 adults, 2 children, and we get a total of 600. That means that boat, not including the boat, on that boat is 600 pounds. Again, in here, there's a little stipulation there. We're not assuming that about Chase. Chase, it's technically Chase on the boat. We're not putting that into account. We're gonna assume that $800 is with him on there. Okay. Okie dokes. And notice 2 adults, 2 children, and for the price, and so Chase would get $250, which is exactly what he wants. He wants it to be greater than $150, which $250 is. All right, so now Chase guides 5 adults. So that means there are no children. So that's 5 adults, 0 children. That means it's 1,000 pounds. he's 200 pounds over. So, which means this is bad days. The boat has sunk. Da-na-na-na, right? Not good. Money wise, though, it's a lot better. 375, but not worth it because now he's dead. Just kidding. He's not dead. They probably just swam to shore and people are not having a very amazing adventure at this point, right? So if you take a look at here, so we're going to graph these. And so the way we're going to graph this, so the blue right here is this blue on the right, and the green inequality, the one on the below, is the work is on the left-hand side. So we've just found the x and y intercepts. And the way we do that is when we're finding the x-intercept, y has to be 0. Because why is that, you ask? On the x-axis right here, the value of y is 0, right? So that's why we plug in y is 0. So 0 in goes 0, and then 200x is equal to 800. And we divide both sides by 200 since 200 times x is equal to 800. So what times 200 will give you 800? 4, right? Or we can just divide both sides by 4. And so here is our x-intercept is 4. So we're going to plug 4 right there. Okay. And then we're going to find our y-intercept. And that's when x is equal to 0. So plug in 0 for x. And then you're going to solve it. You get 100y is equal to 800. Divide both sides by 100. And you get y is equal to 8. You go over here on the y-axis to 8. Make the point. And we here have a solid line because it says equal to, right? There's that equal to underneath. So we're going to just do that. We're not shading it just yet. But if we were, right, I'm going to plug in the 0, 0, right? We always check the point 0, 0. And because 0, 0 is not on this line. And if we plug in 0, 0, we get 0 is less than or equal to 800. Is that true? Yes, that is true, which means we're going to shade, as you notice right here, I put the arrow going down, pointing to the 0, 0. It's like all on this side, okay, to the left of that green, that blue line. Now, we're going to do the next one, which is the money one, right? So the money one, again, for the x-intercept, that's when y is 0. So plug in 0 for y, and you're going to get 75x equal to 150. Divide both sides by 75, and x is equal to 2. So here our x-intercept is 2, right there. I wrote that as a point because technically it's not just x equals to 2, it's 2, 0. And then same thing for the y-intercept. Now x is 0, and so 50y is equal to 150, which means that y is just 3. So here, there's our y-axis right there. And if you notice, it's not parallel for sure, right? And so if we plug in 0, that's what these zeros mean right here. So 0, we're plugging in 0, 0 again, right? Because since the green line is not on 0, 0. And we're going to see, well, that means 0 is greater than or equal to 150. That's not a good idea. No, that's not true for sure. So we're going to be shading on the other side. So that's where we have the arrows pointing up on the other side of the line. So if you notice, it's pointing to one section, right? It's pointing to this middle section right here because it needs to be below the blue but above the green, which means the shaded area, that's where all of our solutions lie. Okay, so any point in here. So if you look at, remember the first trip, it was 2 adults, 2 children. Remember, these were the adults. Here are the children. And so, yep, see how it's in the shaded? Happy days. And if you notice the 5 adults and no children, so that's right over here, 5 adults and no children. I'm gonna put an X there because it's not a solution. Yeah, do you see how it's outside the solution? Yeah, can't have that. So this is a no-go. He should have said no, just should have said no. All right, so another one that would have worked, we talked about this one right here, 0, 6, it's in the shaded area, so it works. So this is if there were 0 adults and only 6 children. I don't know how, like, that's possible here. I don't know if parents would actually send people like that. Maybe if all these children were like older, right? Like, I don't know, what's an adult in raft world? Maybe 14, 15, but you should probably be over 100 pounds at that point. Should be. I don't know. But yeah, so there was a little debate about that. But you could pick any number in here. You can't pick like half numbers, right? Because you can't have, oh, can I have 1.5 children on there? Doesn't work that way. They'll just be half on the boat, right? Not completely on the boat. We'll drag them behind. Yeah, we're not doing that. Sad days, right? So here we could pick like this one. So we can have 1 adult and 5 children. that would work. Or we could have, see, remember it's on the line, and that works as well, because it is a solid line, right? So we could have 2 children and 4 adults. Nope, just kidding. Said that backwards. 2 adults and 4 children. So anything within the shaded area, including the lines, is a solution. Okay, dokes. All righty. So we're going to go on to a little bit of, we already talked about some of those questions, and we did this problem right here, and I said I would finish it. So take this time to finish that if you did not do that already. So this is the green over here on the right. We looked again at the X and Y intercepts. And if you notice that we have X is equal, when we have the X intercept, Y is equal to 0. So Y is plugged in like that. Here we have an equal sign because we're looking for a specific point, right? But we know it is for the inequality here. And same thing with the Y intercept, that's when X equal to 0. And so both X and Y intercepts are at 1, 1. So here are my 2 points. And I tried to use that line thing, but it doesn't have a dashed line thing. So here, my dashed line just like that. And we do know it's going to go up like this because we tried the 0.00, right? It's 0.00. And 0 is definitely not greater than 1. So we're going to be shading, since 0, 0 is on the bottom of this line, we know all of our solutions are going to be on the top. Okay, now for the blue. Okie dokie. So for the X-intercept, we know that Y is equal to 0. So negative X plus 0 is less than 3. Now we just get negative X is less than 3. Well, you need to get rid of that negative. So we're going to just divide both sides by -1. And we get X is equal to, now remember, we divided by negative number, which means we got to flip that inequality. So X is greater than or equal to -3. What am I doing with my life? Sorry. I told you we're finding just a point, which means it's just equal. Duh. Sorry. Equal, equal, equal. So if you guys were confused, I'm sorry about that. Rewind that. Actually, don't rewind that and just keep on watching. So my X-intercept is right here at -3. So we're going to go right here, -3. And my Y-intercept is going to be, this is when X is equal to 0. So actually, let me make this the light blue color. So -0 plus Y is equal to, I was going to do it again, is equal to 3. So -0, just 0. So Y is equal to 3. We're going to go up here, 3. This is greater than or equal to, so we can use a line. Oh, let me use the shape here. Here's me line. Okay. I think it's going to look about like this. Oh, just kidding. Oh, man. That's why this is a little tough. There we go. Sure it crosses both of those points. Happy days. All right, so there's my straight line there. And we're going to plug in 0, 0 for this. So we're going to check the point 0, 0. So it's going to be -0 plus 0. Is that less than or equal to 3? Because 0 is less than or equal to 3. Yeah, 100%. That works. So that means 0, 0 on the side of 0, 0, which is below this line. We're going to shade below. So remember, it needs to be above. So do you see how this this graph is split up into 4 different sections? We've got the top, the left, the right, and the bottom, right? So we have these 4 sections here, right? And so notice, we want this to be above the green line, right? Which means it's not going to be 2 and it's not going to be 4, right? Because those are not above the green line. And then again, we said that it was going to be below this blue line, which means it can't be number 1, which leaves number 3, door number 3. So this is the one where this 3rd section is where it fulfills both criteria, right? So it is above the green line and below the blue line. So this is what we're going to just shade all of this guy right here. So this whole section up until the green line right there, like this. And technically, if this would all be extended out and we would like continue shading all the way, but this is our graph, so that's all we got. Okay, So it would continue on forever and ever like this way. That's the part that would be shaded. So anything in the shaded area would work. Ready? So that's the end of the lesson. And we'll next lesson, we'll practice some more. Bye.